So 21A number 21A number, which number? 18. Okay. And this is in problem set A, right?
Yes.
Okay. So this one says, draw an example Venn diagram where A is a subset of B, right?
It's A intersect.
Oh.
I think.
Part B? Oh, part B.
Part B.
Gotcha. Part B says A intersect B equals the empty set.
It was like not equal. It was not equal and it was an empty set, I think. Yeah.
Oh yeah, not equal to. Yeah, I need to get, unfortunately, guys, I tell you, is it not equal to? Yes, no, it says equal to. All right, so let me make sure I'm on the right page. Don't get old, kids. It really sucks. I think I'm getting karma for making fun of my mom, and she'd always call me, Jeff, can you read this? What's the problem?
Oh, it does say equal to.
Okay, right? Okay.
Equal to and it's an empty set.
It's such a tiny little thing. Okay.
Yeah.
That's good, because this guy, well, he likes to mess with me. He wants to wait until I get right here. But no, it's not even gonna turn on. That's fine. So what does this mean? I want, when I intersect those two sets, what do I want there to be in there? Nothing. So what does that mean visually? Do these two sets have an intersection? Do they have an intersection? Can you can point to it, correct? So there would be stuff in there, correct? So do I want these guys to have an intersection? No. So how would you draw it so they don't have an intersection? I just don't want them to intersect. So I would draw circle A, and I just don't want B to intersect it, right? Yeah. I like it. So when you see the answer to something as an empty set, that means that I want that piece to not exist. I want that to have nothing in it, right? So they can't touch. I love it.
And then if the equal sign did have the line through it,
Yeah.
it would be just a regular.
If it was this would be the answer. Yeah. But if it was equal to, this would be the answer. I like it. Real quick. Oh, go ahead.
Oh, I was gonna ask a different question.
Real quick. Talking about sets. S-E-T-S. These symbols here, they are not interchangeable. What does this symbol mean? It's an element of. So what can be an element of something else is a single thing. A set can't be an element of another set. A set could be a subset of another set. So it's just a question about, we created these symbols for reasons. On a certain level, you're like, why would that make a difference? But of course, it does. So I could say 6 is an element of the set 1, 6, 7. And I could say the set 6, 7 is a subset of 1, 6, 7. Right? Right? But I can't interchange the symbols because an element is for a single piece and the subset symbol is for a subset. There's a problem. We had to identify what symbol to put between things. And some of you guys were using both of these, but that doesn't make any sense. If one works, the other one can't work. Does that make sense? Yes?
What does a line under?
Oh, it's a lot like this versus this. Right? These two and these two. So that is definitely, in fact, we call this a proper subset. And that means that it really is only some of it. Whereas if I had this, that is less than or equal to, it's like got some or all of it. So you could use exactly, can I say this is true? Is 7 less than or equal to 7? Is that true? I love this. Some of you guys are not sure. Is everybody cool with that? Is 7 less than or equal? I could have just went and said, you never know. Yeah. Any moment. Okay. But what's a slightly better way to say that? Isn't 7 just equal to 7? But isn't that one of the options? So this symbol means that this could be equal to that. That's all it means. Now, couple things real quick, and I know somebody's got a question, but this kind of opened up a whole Pandora's box of things. Can I put a symbol between these two things? Is that a subset of that? No, it isn't. Why? Is this contained in this? No. So that's not a subset. You guys follow? I can't put subset between those. Right? In fact, I can't really put anything except like not a subset. I can put that. Right? You guys with? Yes. No. I could say that 1 is an element of each of them. Element is for a single piece. It's for something that's denoted by commas. It's one of those things. Yeah, an entire set, they get their own set of symbols. Yeah. Okay. Is that all right? You guys see that? Because there's a question about, there's the number, what's the number, if I call this A and you call this B, what's the number in A? That's crazy. What's the number in B? That's crazy. That is less than or equal to that, correct? So can I put this symbol in the middle then? No, right? This is a little bit of a higher idea. It doesn't have to do the numbers, it has to do with the elements. Are all the elements here a part of this one? No, I can't do that. In fact, I would just do this instead. It ain't no subset. Just to show off my grammar skills, yeah. Everybody's cool with that idea? Okay. I'm sorry, go ahead. I love how it sounds like we're all lawyers. 2.1 B24G. Oh yeah, okay. All right, let me give you guys an alternate. As I was grading your homework, I was thinking about an alternate way to say this. If I see A or B, let me say this and see if you guys agree. The answer is at least everything in A. Would everybody agree? Because the idea of or really is take A and add to that everything that's in B that's not already in A. That's what A or B means, right? So the answer is at least A. So some people were telling me that this question was what about T or empty set? So what this really means is take T and add to it everything that the empty set has that's not already in T. So it's basically like me saying 7 plus 0. It's the same idea. If I add nothing to 7, it's still 7. If I add nothing to T, it's still T. So the answer is T, whatever that was, yeah. Is that all right, guys? So some of you guys are still mixing up and or, union and intersection. And, the fact that this is or is still not very satisfactory because the way that we use the word or and the way that we use the word and in English doesn't really match math, which is not math's fault. If anything, it's always English's fault because English is one of the weirdest languages on the face of the earth. Except for maybe Finnish. They like to use every letter in their alphabet. I can say that because I'm part Finnish. Yeah.
1.1A probably T.
Second.
1.1A probably T.
1.1 set A, number 18. All right, here we go. Oh yeah, okay. Okay. Oh, I see what's going on. Is that better? Okay, maybe this guy will wake up. So this one says place the numbers 1 through 8 in the circles. And you see the picture on the top of the next page, right? It kind of makes me think I'm in chemistry class. Is that part of the problem? Did you not see the?
I didn't see
So let me show it to everybody. Oh yeah, that'll probably help. Yeah, it kind of sucks a little bit when the next part of the problem goes to the next page. Let me see if anybody knows what I mean by it. So here's the problem at number 18. Place the numbers 1 through 8 in the circles and the vertices of the accompanying cube so that the difference of any two connecting circles is greater than 1. Shite. Another way to say it is you don't have any consecutive numbers connected to each other, right? So now, I don't know if anybody gets the idea. That reminds me of chemistry, although I don't think anything has that structure. I don't know, to be honest, I forget. Was it?
Not something you would learn in regular chemistry.
Oh, well, like this, the structure of how the molecules actually combine. It's not something, okay, all right, stop. Sorry, I'm not gonna suddenly make this a chemistry class. Does this help? I mean, okay. So like, if I put a 3 there, I cannot put a 2 there, or there, or there. So the difference between anything next to each other needs to be at least 2. Does that make sense?
So like probably 12.
Say again?
So it's like probably 12 kind of.
12, but yeah, 12, but just, well, 12 is a little bit different for damn sure. 12 is all about getting and moving around, correct? But the way you might start to approach them might be similar. Yes. Okay. Because it's all about, now again, you guys, I get a feeling that some of you guys still don't understand this. The bulk of the points for any problem I give you like these will be based on the attempts you make to solve it. The answer, you can still do something, but that's going to have the minimal number of points for the problem. Do you understand? The answer is not the most important thing. You've got to let that go. And I know as humans, I've studied humans. I mean, I am a human. And I understand that we want the answer. We are learning approaches to problem solving. We are learning how to teach approaches to problem solving and how to be open to somebody's interpretation. So it's all about the method you use, right? Answer is sort of icing on the cake. Okay. Maybe you guys believe me, I don't know if you do. So really, like on the homework, don't do your work on one sheet and then take the final answer and put it on the, no, I need to see that messiness. I need to see the approaches you took, right? Because maybe one approach was correct and you thought it wasn't, and I'm like, no, this was good. And I can't say that if you don't show that to me, right? Okay. And by the way, on a lot of your homeworks, you're gonna see work, no, stop. Sorry. You're gonna see that a lot because, my God, we've had this discussion. That's the only thing I can work with is your work. That's the only thing I can do something with, right? So please, your cut, show me what you get.
For section 2.3 on number 4.
2, 3, set the number what, sir?
14.
14. Oh, okay. The one about the film? Right, the Roman numeral MCM, this one?
No.
No.
2.3.
2.03. Number 14. Is that better? This guy? Oh, okay. Okay. Major hint. So on the test, I will ask questions like this. I do like to ask a few conceptual questions that aren't really like computational things you can sink your teeth into. I know some of you guys can answer this question, but don't just answer it. What would you tell a student who did not understand the answer to this question, didn't even know how to start? Anybody know what the answer is? Don't say it. Does anybody know what the answer is? Okay, so what would you tell a student who said, I don't even know what to do with this? Okay, good. It's a great place to start. It's not the end of the world. You're going to be fine. We all will know something. The first step to being really good at something is really sucking at something. It's a paraphrase of a quote Jake made in the dictionary. But what would you tell them next? After you said breathe deeply. Yes.
What was the numeral for 8 being base 8?
Say again.
Lower than world record.
Oh, okay, good. So you can kind of, and that's the problem with this, where'd it go? There it is. That's the problem with that, correct? What's the highest single digit? So I like that approach. You would say, okay, what if the problem was just change 8 to base 8? Write down your places, now think about it, right? That's a great, because what would that lead them to realize? That 8 is represented with 1, 0, 10, yeah. You guys kind of with me? Maybe? So again, I don't want to freak you out, but if we had 8 fingers, the incredible likelihood would be we would have a base 8 system. So we would say 1, 2, 3, 4, 5, 6, 7. I don't know if we would call 1, 0. We might even call that 8 instead of 10. Who knows? I don't know if you guys are with me on that or not. It's a little arbitrary that we have a base 10 system. It's just, Anyway, I'll stop. So yeah, okay, good. This problem is not asking you what would you tell a student, but I'd like to make that next step. What would you tell a student, right? So yeah, the 8's a problem because what's the highest single digit in base 8? 7, because once you go past 7, the odometer rolls over, 11. You could really freak people out if you just say to them, there is no symbol for 10 in base 10. Just that statement will freak most people out. Because you're like, of course, I can write 10. No, I can write 5. I can write 9. There is no symbol for 10. There's only symbols for 0 through 9, and every other numerical symbol we have uses those. There's no symbol for 10, correct? I like it. So same idea with base 8, there would be no symbol for 8. We can represent 8 using other symbols. Okay. Anything else from, so again, it's wide open. Homework, quiz corrections, you could ask general conceptual questions, yeah.
Homework 2.2, section B.
2B, which
And
one,
then,
sorry? 10?
10A.
10A.
Specific.
Okay. So what's the very first thing you do when I give you one of our numerals, and you're just missing everything, aren't you? Poor little dude. I give you one of our numerals and I say convert it to whatever, in this case Mayan. What's the very first thing you should do?
Do the place values of
Yes, good. And that is the one that I will just give to you, but I'm almost certain most of you guys know what those are, maybe?
360, 60, and 1, and then the
Not quite.
I went backwards.
Not quite.
Is it 20?
20, yeah. So it's a base 20 system except for that one little hiccup, right? 120 to 360, right? And then it keeps going by multiples of 20 again. So 120, 360. The next one would be
7200.
Yeah, and you always go one place more than you need. So this is definitely more than I need. Some of you guys are doing this. Watch this. Somebody would do this, and then they would take one of these, 7200 minus 926. Do you understand? Do you follow? This is the interesting thing about being a teacher. When you get work, part of your work is seeing if it's right, and then the next level of work is what the hell were they trying to do, right? What was the misunderstanding? So what's the misunderstanding here? What should I be subtracting from every step? I'm going to pick some number or something, and I'm going to subtract it from what? 926, right? I'm not going to subtract 926 from, I can't use something that's larger than the number I have, correct? So if you did that mistake, you're not alone. Several people did that same kind of mistake, and that's a kind of mistake where you're stuck in the math and you're not thinking about the idea. It's easy to get stuck in the math, subtract, divide, and you start subtracting the wrong thing because you're so in the math that you're not seeing what the idea is. So that's too far. I want to do an example problem. Yeah. It always takes me a minute to figure out. Yeah, we'll do an example problem. I'll show you. If I don't go far enough to show you what it would look like. So where did this thing fall apart for you? Whoever asked this. I forgot now.
I did Babylonian instead of Mayan, so I did 160 and 360
Oh, I got
instead of 120 and 360.
So it'll be 160 and 3600.
Yeah,
Oh,
and I
gotcha.
just blended blended them together, so.
So you use the symbols but a one in the base of the other one. That's neat. I like it. Some of you guys are doing.
I understand.
By the way, what do you guys think about somebody who does this? What is that? What civilization is this?
Egyptian.
It's trying to be Egyptian, but they're using the idea of what? Do you guys know? Subtraction. No, it's not a Roman numeral.
It's Babylon.
They're using a Babylonian idea of subtraction, which the Egyptians did not. They didn't indicate it like this. I'll say that because the Egyptians had a lot of that. The Egyptians had fractions, which we won't get into. Mayans had fractions. They had some cool shit. You guys understand? So be careful about the point from that is don't blend. That's neat. I like that idea of like, let's make another civilization where these guys and these guys mingled and they just mixed everything. That sounds like a really cool project where you make a new number system based on 2. That's not what this is about yet. No. Yeah.
Can you go over problem 2 on the first quiz?
Problem 2 on the quiz.
The first one.
So everybody had a problem that said convert something to base. I don't know. I can't remember. Some of you guys had base. Some of you guys had base 8. Some of you guys had base 7, right? Is that what you're talking about? That one?
No, the first quiz, that one, sir?
Oh, first quiz. I'm sorry. That was the Venn diagram one, right?
Yeah.
Where the best thing in the world for a math teacher is to make a mistake on the thing. So I love it. My mistake was I changed one number without being careful about what that would do to everything else. So this is a really good question because I gave you a different kind of problem on the practice test. So you got to be careful about the way things are said. What's the easiest way to do this? Because I don't want to do anybody's problem for them. In general, with Venn diagrams, if you've got any number, but since we got 3, we'll put 3. What's the most important spot to fill in first? The center. So let's make something up. Let's say A, B, C. Just to make this simple, let's just focus on a couple of these things. Let's say that there's 7 that are in A and B. There's 2 that are in A and B and C. And let's say that there's 12 total in B. All right, so this wouldn't be all the information you're given, but just focusing on one piece so that I can make a problem on the fly that actually works. What's the most important number to put in first? Like you said. 2, because that's the one that is in all 3 circles, right? So put the 2 there. Now, A and B, there's supposed to be 7 in there, correct? Can you visually see where A and B is? What shape does it have? I'll accept a few answers. What shape does it have? Oval, elliptical, teardrop maybe, I don't know. So how many total are supposed to be in this little piece? What did I say? 7. How many's in there already? So how many should be right here? 5. You see how that works? So that's why you start in the middle and you sort of spiral out. Now how many's supposed to be in B total? Oh, I need more information, damn it. Let's say that B and C has, who knows, 4, okay? Where's B and C? B and C is here, so how much should go here? Now there's a total of 4 in B and C, correct? There are 12 total in B. Well, how many do I already have in B? 9. 12 total, so what goes here? 3, okay, and then you would keep going. Blah, 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 blah. Okay. Now look at and I don't do this because I think the homework did this too, but I don't do this to confuse you, but you have to understand the way something is said and what it translates to. So look at the practice test number 2. Can anyone pick up on the single word that kind of changes the approach of just a little bit? Yeah, I don't know if it really changes it, but let's see what it does anything. Let's try to do this problem together. Do you see guys say here 10 only study only history and statistics? Okay, so I need how many circles here? What is it about this room? Oh, yeah, I need a history circle. I need a chemistry circle. And I need a, I need a, what is it, statistics. I just put a little T next to my S because my S looks like a 5, so it kind of sucks. So what's the first most important number to put in there? Yeah, 2 students study all 3. Now look at, for example, history and statistics. 10 study only history and statistics. So, the history and statistics is right here, correct? There should be how many total in there? But that would be if I didn't say the word only, so I kind of really hate that I put the word only in there. Only history and statistics would be this piece right here, correct? I like it. So this would be 10. So let's do this. So I'm just realizing I didn't even do that way on the keyboard. Let's take out the word only, because I don't normally use the word only. That actually confuses things. So, for example, why wouldn't I put just an 8 here? Because then 10 people, 2 of them would be studying also chemistry. I don't want to make this tricky, so I'm not sure why I decided to put the word only. So if I take the word only out, let's do this the same way we did the other one. How many would be in here total? 10, and there's already 2 in there, correct? So how many should be here? 8. So see what I mean by you start in the middle and you go spiral out. So now pick another intersection. What about history? What's next here? History and chemistry. 3 study history and chemistry, so how many total should be here is 3, so of course here I put 1. And what about statistics and chemistry? 4 study stats and chemistry, there's already 2 there, so how many should be here? 2. I like it. And then you pick whatever you want to. So how many total history am I supposed to have? 19, there's already 11. So how many should be here? 8. Alright, you guys can finish that up. You guys see that? So I won't put the word only in there because do you see how that would kind of change things? Because you would want 10 right here, because that would mean they would be studying chemistry also, but it just adds another level that doesn't need to be there. Okay, yes?
And so to count how many students are in the total room,
Yep.
you would just count the outer circles?
No. These 2 are distinct people.
Oh, okay.
So you basically just take each number and you add it together.
Oh.
Yeah. And I didn't say there was anybody who didn't take any of them, right? So there's actually nobody out here. Okay, I like it. And by the way, do you see the difference? These numbers indicate number of people, correct? This problem here is a little different because I just said it's region, so this is region 2, this is region 6. So which numbers would indicate A and B? A intersect B. 2 and 6, I love it. So this is numbers indicating regions of the diagram. Okay, I like it, I like it. So again, you can ask something from the quizzes, something from the practice test, something from the homework. Yes?
On the practice test, number 1.
Yep. Do you notice how a couple of these questions involve not B and not A? Do I know them yet? I know A and B in the universe, right? I know the universe. I would just take a minute, considering I'm going to need not B and I'm going to need not A, go ahead and make them. Does that make sense? So what would not A be?
0, -5,
Yeah. Just everything is not an A. And of course, that's why, do you guys see why I have to give you a universe? Otherwise, we'd have to list every damn number there is. So 0, what else in there? -5, -8. Yeah. Is that cool? So basically, you just cover A, and not A is just everything else. Is that helping a little bit? I don't know. What's the specific question about number 1? I don't know if that helps. That helps, because then if you give yourself these bits, so I need to know what not B is, so then I can subtract A from it. So then I can just look between not B and A, and I can do that. There's no reason to try to do not B in your head, and then no, that's crazy. Write it down for yourself. Yeah. So you can look ahead to see what am I going to need to be able to do these problems. Well, I need to know what not A and not B are. Let me write this down. Oh, good. I'm not sure why I haven't really asked you a lot of questions about subset and element, to be honest. I didn't put any of that on here. Apparently it's not that big of a deal to me. I don't know. Yeah.
Section, homework, section 2.2, section B, and then 18B, it's a Braille question.
2B18.
Yeah, and then this second one, B.
Oh, the Braille numbers.
Yeah.
Oh, so the biggest mistake people are making on this one. Jeez, I gotta remind myself how this works. Yeah. So, let me see, where do they have this? There. See, that's a comma. That's a comma, and that's a 1. You guys see that? So some of you guys are putting a 1 when it's really supposed to be a comma. So for example, do you see why that's a comma? Because it's in the second thing, right? Do you guys see what I'm saying? So it's not got to do, so Braille you can imagine, and I'm sure some of you guys have seen Braille somewhere, I'm not even sure if you tried to like close your eyes and pretend like you had to read it. To me it would seem, obviously if I was blind I would learn how to do that, but it seems like, wow. But it's the level that the bump is on that tells them part of what it is, not just the number of things. Otherwise, if it's the number of things, there's not as many things we could represent. So it's got to also be where that thing is. That's one of the biggest mistakes I saw, is that should be, for example, that should be a comma. Right, so how many numbers do I have here?
2.
Yeah, this would be, well, this is what? This is number prefix, right? So this, if they feel this, they know the number's coming. And this, of course, is a comma, and then you keep going, right? Yes. So everywhere you see this, it's a comma. So you can see it's 3 0, not 3 zeros, but it's 3, 3, 3, 3. So it's a relatively big number, correct? Okay. What was 8? Oh, there's 8. Okay, good. So then the problems you have are down here. So you can see those are commas there, commas, yeah. Yes, and then there.
I have a question for the practice test.
And real quick, Ryan, did you have a question about this?
No, I don't.
Okay. Anybody have a question about the Braille problem? Okay. Where are we at?
On number 5 of the practice test for E.
Yeah.
What's the line on top?
Yeah. Anybody remember what the line on top is? Multiply by 1,000. Because remember, how do you write 3,000? 3,000. How would you write 3,000? No line. How would you write 3,000? How do you write 1,000? M. So how would you write 3,000? So, but why can't you do M for 4,000? That breaks one of the fundamental rules of Roman numerals. You can't have 4 the same symbol in a row with nothing in the middle, right? So, for example, why do I say it like that? Because how would I write 3,900? CM. So it's not that you can't have 4 of the same things in the same number. You can't have 4 of the same things in a row without something in the middle. So I can do M, 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 C, M all day long. And again, this isn't something math people made up, it's something the Romans developed. So yeah, right now we can nitpick their rules, but back in the day, they didn't have shit, so that's pretty good compared to nothing. Is that all right? So that's just 4,000. You just take the number underneath it and then multiply by 1,000. And that part's kind of cool. That part makes sense, right? And by the way, I keep saying by the way, but this is, everything we've talked about is a surface level. There's so much more to each of these. Like I said, Egyptians and other civilizations had fractions, they had decimals type things, they had all this other stuff. They had how to multiply, how to add, how to do all this stuff. That would be a whole semester of just that. So we just did surface level if you want. Oh, sorry, Ryan.
Can you show the question 1 for the quiz? Like,
For the quiz?
How to do it?
Oh, let's see. Oh, converting to base 10?
Yeah.
Okay. I really want everybody, here we go. Okay. I want this to make nothing but sense. Basically, everything I say, I want it to make sense, but you know. When I'm given a number in another base already, why does that kick a lot of ass compared to the other possible problems? So if they give me a number 1425 base 6, and they say convert it to base 10, the reason that kicks so much ass is because all the places are filled in. What do I mean by that? What's base 6?
1, 6, 36.
Kick ass. So they're filled in. It's already in base 6. So there's a 1 there, a 4 there, a 2 there, and a 5 there. So now I just have to multiply and add to combine to get my base 10. By the way, I really want you to understand, if I was in base 6, me writing these down makes no sense in base 6. The minute I write these numbers down, I'm already part of the way to base 10. Does that make sense? The number 36 would not make, the number 6 would not make sense in base 6, correct? So when I identify the places, I'm already halfway to our base 10. Does that make sense? I don't know. Okay. If I give you a number like 145 and I want you to convert that to base 6, let me make it the same number, 1425, and I want that to go to base 6. That sucks a little bit because now the places are all empty. Does that make sense? I don't know what the places are in base 6. I don't know what that is. That's the problem. So I know the places in base 6. Do you have to go another one? What's another one? What would another one be? $1,296. I'm with you. And the next one would be 7,200, 70, whatever, 100, who cares? It doesn't matter what it really is. It's going to be too big, right? So make sure you go to the part where you know the next one's too big. Oh yeah, I need to do an example of that. And now you just start one of these, and then you subtract to see how much of the number is left. Is that cool? So some of you guys know the process, you just do the process at the wrong time. Some of you guys do this process for this problem, this process for that problem. Does anyone not see, or I'm not sure how to say it. Can you now see the difference between when to do which process? Yeah, right. You good?
Like after you like write that out, like then.
So how many 216s do I have? One. Plus, how many 36s do I have? 4. Plus. Right? And again, why does it work that way? Because that's how our system works. And so every base n works the same way. And there was one question about, is our system multiplicative, additive, or whatever? It's both. Right? Because why does 1,425 mean 1,425? Because I got 1,000 plus 4 hundreds plus 2 tens plus 5 ones. Right? That's why it is. We don't have to add them together because we've internalized what they mean. If I'm base 6, holy shit, I need to add that stuff together. I have not internalized base 6, right? Okay, I like it. Well, just me. That's why just me this one. Again, if that's not good enough, just let me know. We can do another example. Yes?
I had a question about bases as well. It's on the practice test, number 6B.
This guy here?
No. It's 3,109 base 14.
Oh, 7B.
Yeah.
Okay.
7.
Sorry, I put that in. It's very tricky. Okay, so what about that one? What's the trouble? What would the places be?
1, 14, 496, 2744.
Okay, that sounds about right.
The answer I got just looked a little too big. I don't know if I did it right.
So let's
and you
see.
probably just explained it right.
So what'd you do? How many of these did you use?
3.
That's a problem.
Yeah.
Because this is only 3109.
Yeah.
I can only use one of these, right? 2 of these would be 5,000 something. Do you see that?
Yeah.
Again, don't feel bad about that, that's fine. I'm curious, when you said 3, why did you think you needed 3? And again, I'm just curious.
Converting a base to base 10, you put the number that you see in the place.
Oh!
So I was mixing them up. Like you were
Yes, you were doing this problem.
Yeah.
And you were converting it to base 10.
Yeah.
When the number is already in the base, the places are filled in. When the number is not in the base yet, the places are empty. Does that make sense? Okay. That's why going from ours to a different base sucks, because there's a lot more we don't know. If I'm going from somebody else's to ours, we know everything. We just got to put it together, right? Okay, I like it. Now, real quick, I kind of want to do that problem the wrong way. So let's say I was going to do this problem. But I hate this projector, but it's okay. You're fine. I just don't like the projector in general. So if I'm ever not showing what I'm doing, let me know. I don't like that either. There we go. All right, so I'm going to do this, and watch this. I'm going to make mistakes. So 114, 196. That looks big enough. Great. What's 3109 divided by 196? Somebody help me out. By the way, I'm doing this wrong. I have made a mistake, but we're going to do it. I just want to show you what would happen.
You said 3109 divided by what?
Yeah, 3109 divided by 196, correct? That would be the first step I take, right?
It's 15
15.
and change.
Can anybody see why that's already a problem? That should tell me right there I have made a mistake. Why? Why is that a problem?
Because you're in base 14.
I'm in base 14 and
Number is bigger.
15 does not exist in base 14. 14 does not exist in base 14. Right? There is no split. So when you get a number here that is bigger than your base, math is trying to tell you, hey human, you should have went one more step. This is why I tell you, make sure that you've gone far enough by going too far and crossing it out, right? So what is this supposed to look like? Let's do this for you. Get out of here, you bad, wrong thing. Oh, here. So if I do one of these, I can then subtract to see how much I got left to do, right? So what all that is, what is that? 300 something? 365, I think. Okay. And then I would do how many of these, right? 2 of these would be 380 something, correct? You guys see that? So I just need one of those. And here's a cool trick to subtract. Watch this. If this was 200, wouldn't that be awesome? real quick, I know you all have calculators, I know. If I make this go up by 4 and I make this go up by 4, they're still the same distance apart. So I can do 369 minus 200 is 169. That's easy. Okay. And then what would I do? 14 into that, so I just keep going, how much does this place take care of what's left? How much does the next place take care of what's left? Each time you go, the number you put down can't be equal to or bigger than the base. That tells you made a mistake. Yeah. And again, that's another example of being too much in the math instead of the idea, right?
So you could do like 14 times 12, but you couldn't put 12 in that base, right?
You totally could, totally, yeah, sure. Is
You
it
just
12?
move the
I don't know.
placeholder.
12? And 12 times 14 is something? 168? Why is that completely fine? Because base 14 was the highest single digit I need. 13. Right? And here again is where the book would just, I don't know what the book would say about base 14. We know better. How do I write this officially? If I write this as my answer, what's wrong with that? If you're the teacher, what should you say to the student? What is something you could say? Do you guys understand? That's not the answer, correct? That's wrong. What's the most immediate way to show somebody that's wrong?
Explaining that it's 5 places
Good.
instead of 4.
This
and
would
then-
be 114, 196, 2744, and whatever the shit the next thing is, right?
And then you isolate the 12 together. You
Good.
have to
And the
create
12 is a single place. So, in its repeated understanding of I need whatever's here to be a single place. If you put 2 symbols, it looks like 2 places. And that's why we need a single symbol for the number 12 in base 14, for example, right? Okay. And what should we use for that? We know better than the book. Okay, A is 10, B is 11, C is 12. Cool. All right. Yes?
Can you do 6C on the practice test?
Okay. Just make sure past Jeff did that right. It's, remember, which one's are?
6C.
6C. So this dude.
Yes.
All right. What are the places?
1, 16,
256. And what's in each one? We know what's in each one, right? It's already in base 16, correct? So isn't there a 2 here? What's B? 11. 8. Is that cool? Is that all right?
Yeah, that makes
It's
sense.
already base 16, so I know, and as I do this, I'm already writing base 10 numbers. I might as well write this as a base 10 number because I've already got like the one place identified, right? Okay. And then you just put that together, yeah. I like it. Now, real quick, I do want to point out that the Babylonians, they have a place value system, correct? 160, 3600. Did they care about a single digit in each place? How do you represent the number 55 in Babylonian? 5
5 sticks.
Pac-Man and 5 sticks, and that's all in one place, correct? Doesn't that lead to confusion, though? All right, good. So, yes, you could develop a number system that doesn't care about having a single digit in one place, but that will very easily lead to confusion. Having a single digit in each place really makes it clear what each place is without adding, like if I had to write this for every freaking number so that people could tell, that would suck a lot, right? So you can kind of see the evolution in the improvements made on number systems. It's kind of neat. Just like language evolves. Math is just a foreign language, so it is evolved the same. So again, it could be practice test, it could be quiz, yes?
Homework 2.3. It's section A,
Set A, okay.
and then questions 8 and 9 because they're like the same concept, but like I'm just confused.
Oh, yeah, okay.
Oh, because
I couldn't get access to the website, and so.
Oh, yeah, so, yeah, I could have made you buy access on top of having a book to this website, and I decided not to. But then I wasn't careful with the problems I assigned. Oh, by the way, real quick, before anybody leaves, you might want to get a copy of the answer key, which is here. So if you gotta go, it's no problem. Just make sure you get a copy of that. So in this one, just don't worry about the manipulative website they're talking about. You can actually do the work just by hand. Write a base 4 numeral for the following. Okay, so here's the problem. Can anybody identify what's wrong with this? For base 4, yeah.
There's 5 manipulators.
Yes.
In both the 16's place and 4's place.
Do you remember we watched a video of a young boy working in base 10? And the guy put 14 longs. And of course, 10 longs makes a flat. You guys with me on the terminology with these things? I know we only play with this one day. We're gonna play with them a lot more later this semester. In fact, I'm gonna show you something here in a minute. So, let me see, I need to freeze this thing. So this is fine. But then 1, 2, 3 of these make one of these, correct? Four of them, yeah. 1, 2, 3, 4. For a minute I thought it was base 3. So 4 of these make one of these. So do you see how you can kind of recombine them to get an actual base? So if you try to write it out right now, it'd be 2, 5, 5, 7. Yeah. And that's not good for base 4. I could certainly just put that shit down. In fact, I could take base 10 and just put like 20 of these down. That doesn't mean that represents an actual number. I have to recombine them to make an actual number. Does that make sense? So you could start at the very bottom and kind of work your way up. It's sort of kind of propagate as you go up. Does that make sense? So like you got 7 of these. So 4 of them, of course, make another long. And you're left with 3, so that's good. Right? And then you just keep going. Does that make sense? So on this website they're talking about, to be honest, it's really, I'm going to show you some of the manipulative stuff throughout the semester. They're not the best, so you can actually just do this by thinking about it. Okay. In fact, I kind of want to show you, yeah, let's do this. Right on the heels of that question, and you said number 9 also, but I think it's
I think the same thing, just like the reverse.
yeah, okay.
A,
By the
specific.
way, I appreciate those of you who are actually drawing all the lines across and so forth. You don't have to do that. Just represent a long, represent a flat, represent a cube. It's a great time to learn how to make a cube very quickly. Right? Is anybody not able to? You don't have to tell yourself. There's 2 ways, real quick. There's 2 ways to make a cube. One way is the old standard of putting a square and then another square and then just connecting the edges. Right? Now if I did that more carefully, it looked better. And then I just do this way, which is just, and this is more like not the way the artsy fartsy people do it with the. Anybody here do art and you have the vanishing point and you, anybody? I make it sound like it's,
I
you
mean,
do
I'm
art.
taking a class that involves that, yeah.
But it's not an
It's
art
not.
class?
It is an art class.
Okay, okay.
I'm just not an art major. That's why.
No, I didn't say, you don't have to be an art major. Just anybody taking an art class, doing vanishing, okay. Anyway, so you don't have to be an artist to do any of these problems. Just make it really clear what's a cube, what's a flat, what's a long, so forth, right? So let me show you something very quickly here. Let's see, this is really quick. Here we go. So let's say I have, let me see if you want, no, I don't want to use this, get out. These are base, I think they were base show you exactly what I wanted to, that's okay. Where are our base 5? Our base 5 is somewhere. So, this is base 4, right? So if let me see, I want to do this. If I have any singles in here, let's see. Oh, this is horrific. Some of these are 6, and some of these are 5, and some of these are 4. That's amazing. Okay. There we go. Oh no, that's a 6. There's a 3. What is happening here? Okay. All right. So just a really quick. So if I have these, this is kind of like a physical interpretation of what we just did. So this would be sort of like 4, 0, base 4, which is an issue, correct? So just to make sure everybody understood what I was saying earlier, because that was more like you have to draw it, you can't really see it. If I put these all together, now it makes 1, 0, 0, right? I got 1 flat, no longs, no units, which is what that really should be. There's a really cool problem in the book where it asks you if you saw a shortcut. So I can't show you what I wanted to because they needed base 5, which is what this should have been, but it isn't. Cool. Does anybody remember that one? There's a problem that said, I should have looked this up. Yes, from base 2 to base 8. So, for example, all right. So if I have a base 2 number, let's say I have this base 2 number. Yeah. Sure, okay. And I want to convert that to base 8, I think it was. Trying to remember now, yes. So watch this is kind of cool. So base 8 would be 1, 8, and then 64, right? And watch, this is kind of cool. How many ones do I have? So see, everything below 8 is going to go in the ones place. Does that make sense? Because if I put a 1, 1, 1, what's that number? 1, 1, 1, that's the number 7. Because the minute I hit 8, this would be a 1 here, correct? Okay, so watch, this is kind of cool. What is the total here? How many is total here? I got 1, 4, and 1, 2. How many total? 6. How many total 8s do I have here? No 8s, no 16s, but I do have a 32, which is how many 8s? 4. There you go. So this number in base 2 is this number in base 8. And you would expect there to be a shortcut between like base 2 and base 4 and base 8. Maybe base 3 and base 6 and base 9. There might be a shortcut. You can see, so that was the point of that problem, was you had to do several and try to see if you can notice a shortcut. And the shortcut is take every group of 3, because then that becomes each successive place of 8. I don't know if that makes sense, and it's a little bit of an extra thing, but I just want to explain that problem because a lot of people didn't know what it was trying to say. That's an extra. That's a little icing on top of the cake that is our homework. So it's okay if you don't quite get this. Okay. I do want to spend a little bit of time on that problem-solving sheet we didn't finish. So let me do that right now, and then we'll just open it back up to any specific questions. Which ones did we do completely? We talked about number 1, correct? Did we? Maybe we didn't talk about any of these really. I think I just talked about a couple. So I don't know if you guys remember what you guys did together in your groups. I think most of you guys found 3 different methods, maybe 2 or 3. Can somebody remember what was one method you came up with to determine what the numbers were? Some of you guys claim that you just guessed and got real lucky, and your first guess was just the answer. Right? Yes?
Variable, okay, so what would that look like if I used a variable?
X plus.
Yeah, so the first number could be x, and the next consecutive number would be x. No, it's a consecutive number, right? Not consecutive odd or consecutive even.
Oh, sorry, yeah.
X plus 1, x plus 2, and that should be 78. And then you just solve that using good old algebra. Is that cool? Yes, no, maybe so? Now, I really like the answer, I think I remember who it was. Somebody said, yeah, I just guessed. And it's like, did you totally just randomly guess? And they said, no, I knew it had to be in the 20s. All right, so good. So that's not random guess. That's inferential guess. You actually used a little bit of information about the problem to really kind of refine your guess, and then you got lucky that it was exactly right. So you could sort of guess, but you know, I didn't see anybody do this. What do you get when you divide 78 by 3? I think maybe one group did this.
26.
Yeah, you get 26. So what that means is 26 plus 26 plus 26 is 78, correct? That answer sucks, it's not what we need, but look what I can do. I can take that down to 25, and that can take that up to 27. And of course that adds to be the same thing, correct? If I take 1 away and add 1, it comes out to the same sum. Yes?
I did something similar, but I did 75 divided by 3, because then it's all
Oh, okay.
25.
Sure?
And I just knew that off the bat, and then I just did add 1
Ooh, I
and
like
2.
it. So that's an adjustment to this.
Mhm.
That kicks so much ass. This is what I want you to get excited when a student comes up. I mean, there's an example of a method that beautifully works that I would never have thought of. I just don't look at it that way. It's not like some huge earth-shaking thing. Even when the approach they take won't work, identify why their logic made sense. It's going to be really hard for a student. I mean, you're not going to have a student and you say, what's 1 plus 3? And they say yellow, in which case you have nothing to like, you're with me? That kind of thing's not going to happen too often. There's normally going to be something that you can say, okay, I can see why you thought to do this. Here's why that doesn't work, and here's what you should try to think about, that kind of thing. You want to try to connect what they really get with the next step that they're missing. Is there another way? So this is basically 3 ways already. This is algebraic. Then there's the random guess that sort of is guided by the fact that you know this should be in the 20s. And then there's the divide by 3 and adjust. And then there's like a 4th way, which is sort of related to this way. All right, yes?
Solve a simpler problem with 25, 25, 25, 75. That's what I did.
Where'd the 25s come from?
Just because it's close to 26 and I thought about 40.
But how did you know 26?
Oh,
So remember-
maybe, I don't know.
So maybe you did something like what she did.
Yeah.
Okay. All right. This next one, I think we talked about. Maybe not. Guess and test, right? So the perimeter is 58 feet, and the area is 198 square feet. How does that? So here's the problem students have all the time with rectangular area perimeter problems. Eternally, they will not go all the way around. Most of the time, they go halfway. And so on a lot of my algebra tests, back in the day when I was legally allowed to teach algebra, you would see like every other test I would say only halfway, only halfway, only halfway. So all the way around is 58 feet. So what must the length plus the width be?
Half of that.
Say again?
Half of that.
Half of that.
Which
Is
is.
everybody with me? If I do length plus width, I've gone halfway. So let's not make a mistake. Let's use it to our advantage. Length plus width is 29. Is that cool? What does length times width have to be? 198. So let me see if I can dredge at some algebra memories. Some of you guys, it's closer to the surface than others. Remember factoring x squared plus 6x plus 5? You had to find 2 numbers that multiplied to be 5 and had to be 6, correct? Isn't that exactly this kind of problem? So when I teach factoring to students, I try to get them to see how that piece of the problem has nothing to do with algebra. It's just a number puzzle, right? It could come from a problem like this. So now you just got to figure out two numbers that add to be 29 and multiply by 198, and I don't give a shit which one they do first. So a lot of times algebra teachers will teach find the factors first, and then no, there's no reason. I could try 14 and 15. Why? Because they add it to be 29, right? But 14 times 15 is not 198. So I think we did talk about this, didn't we? I remember, because we got close, and then we sort of adjusted. What is 14 times 15? What's a quick way to do 14 times 15? Man, you guys are going to get really sick of me, I'm sorry.
210.
14 times 15 is 7 times 2 times 15 is 7 times 30. You guys see that? Is that cool? Whenever I have an even, some of you guys are like, stop, Jeff. It's okay. And I know you have a calculator, but 14 times 15 is 7 times 2 times 15, correct? Which is 7 times 30, which is easier because 7 times 3 is 21, and then just add a 0, which is too much. Which means I'm close. So what's better about 13 and 16 off the bat? What number is that going to end in? 8. What is 13 times 16? Now, do I have a quick way to do this one? No, it's just because that one had a 15. But you could do 10 times 16 is 160, 3 times 16 is 48. That makes 208, so that went the wrong way, right? I'm getting closer though, right? That was 210, that's 208. So now you can see how guess and check can be refined. Why wouldn't I waste any time with 12 times 17?
It's 2 times 7.
It's not going to end in an 8, right? What about 11 times 18? Okay, that one makes sense to try, and 11 times 18 is, thankfully, 198, so I'll stop talking about it. Okay. So what does that mean? What does that mean? Those numbers we found. Yes, it's the length and the width. It doesn't matter which is which, but normally we call the length the longer one. So you say the length is 18 and the width is 11. Is that all right? Okay. All right, I'll stop talking about that one. I was really curious about number 3 because I don't think we talked about this one at all, but a lot of you guys seem to get it. Yeah, triangular field, which is part of the reason why I don't know if you guys remember we did that triangle problem about counting the dots and different ways to do it. Farmer wants to build a fence to enclose a triangular field that is 180 feet on each side. So it's 180 feet on each side. Fence post costs $8 each. If he's going to put a post in each corner, and then every 6 feet along each side. So this becomes a counting problem, right? So the funny thing is, well, all right, what time is it? Okay. I want to see if I needed to cut to the chase. If I do one side, I can just multiply by 3. So if I started this post and I just count how many end before this one, I can just multiply by 3. So it's sort of like that one triangle problem we did. There were multiple ways to count how many dots. This is essentially the same thing. Now, of course, here there's a level of, well, how many posts can I put along here? Yeah, so it's 180. So total of 180 feet. So the next one's got to be 6 feet further down, right? 6 feet, 6 feet, 6 feet. So if there's a post here, we can just forget about it for a minute. 6 feet later, I'm going to put 1. So 180 divided by 6, I'm going to put 30. That gets me all the way to this corner, correct? Okay. So there's 30, 30, 30. Is that all right? Oh, you guys, some of you guys are like, I've checked out too. I don't know. So how many total posts do I have? 90. And then I can figure out the total cost for all the posts, right? Okay. So that's one way to do that problem. And do you remember we did, this is one method we used to count the dots? Okay, maybe. Okay. And then let's see. Let's do this.
Wait,
Yes.
Back at 3, it says, it's gonna put one on each corner and
Yep.
one every 6 feet, so wouldn't it be 30 times 3 and then plus 3 for the ones at each corner?
If I go 6 feet and then put one, 30 posts later, I'm including this one. So this is 30, this is 30, and this is 30, so I've already counted the posts. But so nothing wrong with what you're saying, because it does feel like they're separate. But the fact that I started counting 1 at 6, I would end 30 at this post right there, so I'm including each grouping. But that is a consideration. For the beginning, you've gotta make sure you count all the freaking posts. And those corners feel like they're gonna be separate. And they could be, depending on the way that you decide to count the dots that represent the posts. Okay. Anyone here that's desperately, because I wanted to maybe look at the ones on the practice test, but let's see real quick. This one we talked about a little bit. That one's probably the weirdest one on here, to be honest. Number 4. I remember talking about an approach you could take. Number 5 was, we saw that one video with determining the pattern. So, for example, did anybody do anything with this here? If you do 6 to the 0 is 1, 6 to the first is 6, 6 squared is 36, 6 cubed is, yeah, so you very quickly see what's happening with 6, correct? So that one's easy. But then you do the same thing with the other ones and you notice you gotta see the pattern. And we discussed that last time about going far enough until the counter starts over, and then just seeing where you are in the pattern, right? Okay. This one's a little bit boring. Sorry. It's just the part A, they don't give you enough information at first. So part B, it says, what if we told you we sold 20 tickets so far? Then it becomes an exact algebra problem. I don't know if you guys even remember, every algebra class has one of these. Adult tickets cost $2, kids tickets cost 50 cents, blah, blah, blah. I don't know if that sounds any familiar to anybody? Some of you guys? Number 7 is the most interesting one in here, I think. So I was about to say you can't blame a student for thinking this will work, but I don't know if anybody out here actually thinks this will work. So he's got to find 8 consecutive numbers whose sum is 124. So he's like, okay, my teacher told me about solve a simple problem. I don't like this 8 shit. Let me make it a simple problem. Maybe 4 numbers whose sum is 62. Do you guys see an immediate problem with that? Let me see, what can I say? Give me 2 consecutive numbers.
1 and 2.
Say again?
1 and 2.
Kick ass, run cells. What's 1 plus 2? 3. If I do 1, 2, 3, 4, does that add up to be twice 3? Does that add up to be 6? No. So they went too far with their simple. Do you understand what I'm saying? If you cut in half the number of consecutive digits, you're not cutting in half what they add up to be, because you just chopped out the highest numbers from it, right? So it's not going to work. Yeah. Now you could argue. Let's see, I don't know how much time I want to put into this. There's a way to maybe make something like this work, but not. I'd have to see what he actually did, and then he'll show us what he actually did, which is unfortunate. Now, let's look at the problems on the practice test. One of my favorite problems is number 9. And I have no idea if anybody tried that. Number 8 and number 10 are incredibly awesome in their own way, but they're boring compared to number 9. Number 9 is nifty. Did anybody think they got number 9 answered? So we got 1 maybe, and the rest of you are like, dude, just freaking time the train, man. Right? On some level, you got to be like, just freaking let it go and time it. Leave me alone. So, okay. So, are you willing to share with us how you tried to do it?
So I have a model train at home.
Oh, okay.
And so
That kicks a lot of
I
ass.
actually grabbed it and I was like, looking at it and I was imagining a tunnel. So the train begins to go in the tunnel, so you time it right then when it's starting. The front of the train is going in, that's 1. That's 2 miles right there.
Wish I put that in train. Right.
So you start timing it when it enters the tunnel right then, that's,
So the tunnel's 2 miles and the train is 2 miles.
yeah.
So this is right when you're gonna start timing it, right?
Yeah.
Okay.
And then you account for it being in the tunnel. And then you account for the end of it coming out, so that's a third segment.
Okay. Notice I give a little hint as to what to do with some of this. I asked for how many minutes. Does anyone know if I'm going 60 miles an hour, how many miles per minute am I going? So 60 miles per hour. An hour is how many minutes? 60 minutes. How does that reduce? So 1 mile per minute. Yes? If you're going 60 miles an hour, you're going a mile a minute. That makes this problem much easier. If the minute that train, right before it's going to go in the tunnel, how many minutes until it's entirely in the tunnel? 2 minutes. In fact, a really nice way to look at this problem, drawing a picture is almost required for sure. Think about a dude at the end of the tunnel, because when is the problem going to be done? When am I going to stop the stopwatch? When the end of the train leaves the tunnel, correct? So this dude, how long until he gets in the tunnel? Well, it's 2 miles, so it's going to take 2 minutes. That mile a minute kicks so much ass. It makes the math easy. So in 2 minutes, the train is going to be in the tunnel. All right, it's really bad. I don't care. So 2 minutes, it's in the tunnel. So of course, how many more minutes until it's entirely out of the tunnel? If it took 2 minutes for it to get entirely in, it's going to take 2 minutes for it to get entirely out. Does that make sense? Maybe. So if you think about it, how many total miles does this have to go until this guy is out? It's got to go 4 miles. And if it's a mile a minute, it's going to take 4 minutes. Okay. Maybe. Let me do this. I'm going to give you the answer key. I want you to look through it. Let me know if you have questions. Let me know if I got anything wrong. I'm averaging about a 97 on my answer keys. Yes. All chapter 2 and chapter 1 homework due Thursday. Yeah. Let's have a talk about homework. If for some reason you're still doing like section 2 homework or something, and you haven't even started chapter 1, you want to stop doing every problem. I'm not saying I'm going to be cool with that. Right, but this is all about making your education your own. I don't know if I told you about both walk uphill both ways. Did I already have this discussion with you guys about the homework? So I already talked to you guys about I had 3 jobs and so forth, and my homework suffered. I did enough of the homework so I knew I was going to be okay in the test, but I couldn't finish all the homework. There's no way in hell I could, right? So you have to make sure you do not come to the test with entire sections of homework you haven't even looked at. So just go, that's nice, Jeff. You can ask me to do whatever you want to. I'm going to do what I can to prepare for the test. And then you turn that stuff in. I'm going to put it on top, finish, right? But you just do what you can, right? So there's certain things I ask for, and there's certain things you have time to do. You got to do the best for yourself.
Does that make sense? So did anybody hear me just now say that I'm cool if you don't do enough of the homework and you got 100 homework? Did I say that? Some of you guys are saying yes. I never said that. I'm still going to say finish this. You're still going to get half credit and all this kind of stuff. Your most important thing is to get ready for the test because the tests are the heaviest weighted things, correct? So everything you do should be getting geared towards doing those tests. That doesn't mean quizzes aren't important. It doesn't mean homework's not important. It just means getting all of that gets you ready for the test, right? Okay. It's pretty cool with that. So don't come to the test without having done any of section 1, 2, for example. Just do every other problem, or whatever you can, just to get some practice, and then finish it whenever you can. Okay, maybe. Because I basically did that without the teacher saying we can't, because that's what I had to do. So you feel free to do the same thing. Anything else? Any other questions from quizzes or practice tests or homework or general? And real quick, if anybody's just ready, you can head out anytime you want to. Any review day, if you are ready for the test, you don't have to sit here staring at me. But does anyone have more questions? Does everything look okay on my answer key? Yes?
So for number 2, you don't have to take out the word only. Does that affect the...
No, because I actually realized I sort of mentally took the word only out already. So the work I did on the answer key is without the onlys. So I decided I didn't want to put an extra spin on that wasn't really necessary. Yes?
Are that like the numerals and all the stuff on the test, like the Egyptian and all that?
I'll give you the same stuff I've given you for the quizzes. Yeah. So like there's the Mayan positions, I did give you the Roman numerals, didn't I?
Mm-hmm.
Yeah, I should make you memorize them, but I'm not going to. I'm just not going to give you the Mayan symbols, the Babylonian symbols. What was the? I think that's it. I'm going to give you the Egyptian symbols. I'm going to give you the Roman numerals. I'm going to give you the Mayan positional values. Is there something else? I think that's it.
Something else.
Huh?
I'll take something else.
You'll take something else?
I
I think
won't
that's
say
it.
no.
I think that's it. Yes.
So your work on the diagram on that page and the work on the answer key is a little different. Cause you have like a 2
Yes.
in the intersect of,
Oh, come on, Jen. Did I really? This is why I'm averaging like a 97. I think
Cause I got 39 students.
right here, see this? For study only statistics and chemistry. So I sort of did this part
Oh, okay.
as if the only was still there. So I should have crossed the only out for myself.
So the 2 is
So
right.
yeah, let's change this. Let's make this right. So this would be a 2. So that would change this to be a what? A 9. I love it. So then how many total people would there be? I think that's...
39.
What about the other section, the statistics section?
Yeah, so now how many in this one? Statistics were,
9.
where'd they go? Statistics, 21. Okay, so there's 2, 4, 12, so there should be 9. 9? Does that make sense? Because that being going down by 2 makes those go up by 2, which would add 2 more people, so that should add to be 39. Yeah. Just for some reason these, I don't know why they're cursed for me this semester, these Venn diagrams. They're normally my favorite little things. But thank you for picking up on that. So yeah, I should have crossed these onlys out. Yeah.
I just got a quick question about like doing the quiz corrections. Do we just like write it in pen? Is like the right answer on the test?
If you're certain you're not going to make any mistakes as you're writing in pen.
Okay.
Yeah,
But
so
it-
in general,
it doesn't-
you could write in pen all you want to if you make no mistakes.
Okay. So you can't write it in
The
pen?
minute you make a mistake and have to cross this shit out, you better stop writing in pen. Yeah, okay. Yeah.
So for the Venn diagram, when we're adding, like, them all together, do we just add every single number together?
Yeah, each number is a distinct group of people. Does that make sense? So yeah, you add each number. So these are 2 distinct people, these are 2 distinct people, this is 1 distinct person. Right? Okay. Yes?
Can we use calculators in the
Yes. You can use calculators. I'll bring some extra in case you don't have one or yours dies or something weird happens. bring, I've got a set of scientific calculators in case people are not used to the TI stuff. And don't forget, guys, I will tell you this, I still haven't gotten this schedule, which is kind of killing me, but there is one tutor in the Math Study Center who feels very comfortable tutoring this, because is this course required for math majors? Hell no. So in terms of tutoring, it's always weird because it's math that they could handle, but it's math with extra stuff thrown in, correct? And that's the part they feel really uncomfortable with. One tutor, Mark Riley, I don't know if anybody ever been to the Math Study Center. Mark Riley, he's currently in a wheelchair, I think still. He's had some feet issues and so forth. He's really good. He's one of my best tutors, or not mine anymore. I'm not in charge of that place. He feels very comfortable tutoring 125, so he's already got some a recommendation from over here. Yeah, right there. Yeah. Thank you. Did anybody not get their quiz back before people leave? Yep. Let's see if we make it quick of myself. Oh, right there's everything. Let's see, which one did you have? Oh, this is quiz 1. Shoot, we have quiz 1.
Jeff, do you want me to stop the recording?
Thank you.